There's groups, flexibility. I think you can help the organization by having slightly different questions. Happy to hear.
Good. Yeah. Any other questions? No. All right, he's left. Great. Okay. Let's crack on with the next one. Theory of constraints. Unless you want to. Oh, we're almost done anyway. I probably should keep going, otherwise we'll run out of time. All right. So theory of constraints. Has anyone ever come across this before, or know what theory of constraints is? No. Is anyone studying mechanical engineering or mechatronics or any of that sort of engineering? Nope. Okay. You're all hardcore programmers. Great. So the theory of constraints was made in, I think, the 70s or the 80s. This guy called Eli Goldratt published a book called The Goal, and it's about a manager in a manufacturing plant, and his life's kind of falling apart. His marriage is falling apart, and his plant is kind of in all this disarray, and it's about to get shut down. He has 6 months to improve the productivity of the plant before it gets completely wiped off. And so he talks to this physicist who tells him about essentially what becomes the theory of constraints. And it's kind of the book's about how he improves the productivity of his plant and kind of goes about implementing these ideas to make things better. This book, when it came out in the 80s, revolutionized American manufacturing and kind of just revolutionized management since then. Now, why are we talking about it in software engineering? Because, well, the first thing is we wanted to develop you as leaders and managers in this course. Some of you might go onto a management pathway, some of you might not, but either way, it's good to understand both about people and about management processes. So we're going to be talking about the latter today. And what you'll also notice is that a lot of the professional, we call this the professional lectures, the one with the dog emoji as leadership on the lecture schedule. These sort of professional lectures will actually tie in a lot to the technical lectures we discuss as well. Like next week when we talk about risk, you'll see that come up again when we do feature flags, when we do observability, which are all very, very technical topics. This one, you might be able to start to see how we can apply this in software, software process, as well as just like software development generally. Okay, so we're going to talk about what is the theory of constraints, how does it apply to software engineering, and the 5 focusing steps, which are a process of ongoing improvement. Okay, you're the head of process engineering in a manufacturing company. Your job is to oversee all the processes that take place and make them as optimal as possible. I'm just going to move this out of the way so you can see. Yeah, it's here. So here, imagine some sort of process, right? Like in manufacturing, you've got sales, design, operations, customer invoicing, payment collection, or if you want to keep your software hats on, it's the requirements analysis, the design, the coding, the PR review, the CI running. And here's the report showing the efficiency of each sub-process. So my question to you is, maybe 15 seconds to discuss with the person next to you, where will you focus most of your attention and where will you avoid putting any of your attention to improve this process as a whole? So I've got a bunch of sub-processes here. What are we going to focus on to improve? Got 10 seconds. All right, cool. Who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D, E, and F? Okay, cool. So you've made your decision, and then you get another piece of data. Now you get another piece of data. And this shows the maximum capacity of each sub-process. Have you changed your mind? 10 seconds, then we'll talk about it. All right, who's changed their mind? Yes, Luke.
Since like capacity, capacity involved in the
Yeah. Mhm. Yes, I mean, I would say that focusing on something includes throwing money and people at it, right? We'll find that's actually the sort of last resort, and there's a way you can improve the process without spending more money. Anyone else? What was your name, sorry? No, I think you changed your mind as well. Yeah. Yeah. Yeah, cool. I like how you've used the word bottleneck, and we'll talk more about that in a second. My other question here is, what's the maximum capacity of this system, right? Like imagine this is tons per hour or units per hour. What's the maximum throughput, the amount of stuff that comes out the other end? 10, right? Now, many of you said, many of you said B. The answer is actually D. So D is what we call the constraint or the weakest link. And so if we try to optimize process B, go back up here, what we end up with is, let's say this goes to 20 tons per hour. So now we've got 20 tons per hour, but this C can only handle 14. So now you've just got all this, if you think of this as like a manufacturing plant, all this stuff piled up right before C waiting to go in. Yeah. Yes, you're right. I wouldn't call it the average throughput just because that deceives you into thinking it's an average. But the throughput of the entire system is the throughput of the weakest link, which is 10. And that kind of, in a nutshell, is the theory of constraints. So every single system, every single process has a limiting factor or a constraint, a weakest link. And the only way you can improve the productivity or the throughput of the system as a whole is by improving the constraint. And if you try to improve things that aren't the constraint, that won't probably actually slow things down. And it's like the idea that a chain is only as strong as its weakest link. And if you focus on improving the constraint, that is how to improve profitability and performance, or whatever you're trying to optimize. So the core idea, again, if you strengthen other links in the chain, that will put more weight on your weakest link, right? Like in the manufacturing example, you've got a big pile of stuff sitting before your bottleneck. When they're properly identified and managed, constraints are, again, the fastest route to significant improvement, and you don't necessarily have to throw more money, more resources at it. You can just simply rearrange the pieces that you have and generate more throughput. Who's been bushwalking? Awesome, most of you. When you're bushwalking, who has encountered a time when they say, oh, let's put the slowest person at the front? A few of you? Yep. Do you know why they do that? Yeah. Sorry? So you don't lose them? Yeah, that's one thing. Anyone else? That's so mean. Okay, who's the slowest person here? Yeah, at the back. Yeah. Anyone else? You're exactly right. The group only moves as fast as the slowest person. And actually, if you have the slowest people at the front, the group as a whole will move faster. It's this really interesting phenomenon. So let's say, here's our bush track, right? And you can think of throughput as the amount of distance that we've covered as a whole, right? The amount of distance behind the last person. Now, if we put the slowest person at the back, you know what happens, right? And the fastest people at the front. Here's the people in the middle. I'm running out of time. These distances just increase, right? This distance goes up, and poor old mate down the back, he's going to get left behind. They're going to get left behind. So what we do is we say, okay, well, let's put the slowest person at the front. And what you find is that you're decreasing this. We can kind of think of this as like amount of inventory or the amount of stuff that's in the pipeline. And the less stuff you have in the pipeline, the less elongated and less lead time there is. And funnily enough, the system moves faster as a whole. So in the book, this guy goes bushwalking with his kid, and he realizes this exact thing where the slow kids, if you put them at the front, then everyone will move faster. Now, what's another thing that they do when you go bushwalking with the slowest person? They say, okay, slowest person at the front, and what? Do you just like leave them and they just walk like everyone else, or do we try to help them? You like take stuff out of their pack, right? Get the poor slow person being humiliated. All right, it's empty your pack and distribute it across everyone else's packs. But the reason you want to do that, right, is because if they have less in their pack, then they go faster. And if they go faster, what happens? Everyone goes faster, right? The whole group moves more quickly. This is all theory of constraints. So what you're doing is improving the sort of efficiency of the individual process, right? And then you're subordinating everything else to the process. That's what I had to say about bushwalking. So let's now go through the 5 steps, the 5 focusing steps of theory of constraints. And this is a process of ongoing improvement. The first step is to identify the constraint. It's really important that you identify the right constraint, because if you identify the wrong constraint, then the system as a whole won't improve, right? You have to fix the weakest link. A constraint is different from a bottleneck. There might be a whole series of weak links in your chain, but there's one of them that's the weakest link, and that's the path to improvement. There's 3 different forms of constraints, again, with our manufacturing hats on. There's resource constraints, and you can literally think of this in computing, like a particular machine doesn't have the compute power to go through a certain number of records, so that puts a bottleneck in the system. Policy constraints, when we talk about risk, we'll talk about introducing policies and ways of mitigating risk through checks and balances. But sometimes those practices or metrics, they artificially distort flow and they slow things down needlessly. So they provide constraints as well. And the last one is permanent constraints, which is just the things that are part of, they're sort of like essential complexity in a software problem, things that you can't necessarily get rid of. Got 2 minutes, all right. The second step is to exploit the constraint. And this you can kind of think of as taking stuff out of the slow person's pack, right? You want to make it as efficient as possible and maximize utilization. So things like in your manufacturing plant, if you have a bottleneck process, right? Like maybe it's welding or something, and everyone goes on lunch for an hour and the whole welding plant is just doing nothing for an hour. Do you think that's good? No, right? Like you want to keep it going all the time to maximize its availability. If you have things like only 50% of the goods coming into that process get used because they've got bad quality input, do you think that's good? No, right? You want to have good quality input so that 100% of everything that's coming out of that process is good and you can use. Again, exploiting the constraint that exists. This doesn't mean using more money or resources necessarily. This just means squeezing out what you have. The next one is where we move the slowest person to the front. We subordinate everything else to the constraint. I kind of have already talked about this, but we essentially bring the constraint to the front of the line. In manufacturing, this is called choking the release of raw material in line with the constraint, and the constraint should never be starved. It should always be working at 100% capacity. Okay, the last step, sorry, not the last step, but the 4th step is called elevating the constraint. And this is where we say, okay, let's add more people, let's add more compute power, let's add more money. Most people sort of jump straight to this step, but as we've said, there's rearranging of the pieces you can do before you get to elevation. As I said, implementing the first 3 steps properly typically expose a minimum of 30% hidden capacity. In software, that's kind of less. I don't think this is much of a thing, but you get the idea. Last step, rinse and repeat. Find the next constraint, because there will now be a new weakest link, which you need to, again, identify, exploit, subordinate, and elevate. I had this real quick thing about tutor timetabling, but we've run out of time. So all I'll say is, when we do tutor timetabling, what we do is we say, get everyone's preferences, and then we order them by the number of possible preferences, and you allocate the constraints first. Because if you just start at Monday 9 AM and go, okay, 1, 2, 3, 4, you end up with, you're saying, old mate here who only preference Wednesday at 2 p.m., that's already been taken, and you don't necessarily get that order. So you do the constraints first, and the people who put down like 100 availabilities, you can just mix and match them anywhere. Does that make sense? Awesome. All right. If you are interested in this, again, if you're a nerd about management like I am, read The Goal. It's actually a page turner, a really good novel if you like reading. This is where you can read some more information about theory of constraints as well. Are there any questions? No. Awesome. Okay. 201. I almost was on time. Please post in the forum if you've got any questions. And next Wednesday, there's no lecture. I'll put all this web CMS. We're going to do a bunch of pre-records, including Hayden's one on risk. And then Thursday, we'll be back in here. And then you've got your mentoring and stuff where you get your groups. So thanks, everyone. See ya.